Hi, recording is rolling. It is Friday the 13th of September. So I'm going to help you guys out a little bit on these projectile graphs. You guys remember yesterday I gave you guys your next take-home quiz. We're going to look a little bit at those. You guys have a free response question on your desk. We're going to take a lot of time to go through that. A bunch of you guys just turned in these projectile puzzles. Remember, the ones I'm scoring are number 1 through 8 on the left, number 11 through 17 on the right, and then on the back side, just the left side scenario. So we've gone over a bunch of that in class last few days. And I'll be grading those over the weekend. Okay, of course, your guys' take-home quiz. Turn this in on Monday. Your guys' linear motion quizzes. I'm still waiting on a few quizzes, but coming soon, so I can get this back to you guys. AP Classroom, you guys remember the progress check? I saw some of you guys turned that in already, so awesome if you have. It's mostly linear motion. There's some projectile questions. I want to go over as many solutions as I can on Monday, so have that done by then. I got the due date set, I think, like 8 in the morning. So, right. All right, let's see what you think. Actually, right before these projectile graphs, they point out something on your guys' AP equation bank. All right, so guys, if you look at these equations, so this is what AP allows you to use during the exam. So it's like open formula, this page. So it's probably good to know what formulas are where, and then as the year goes on, of course, like how to use all these. But pretty much, here's where we are so far in the class. Here's your 3 kinematic formulas. Now, AP writes them a little bit differently. We're gonna talk about that. So this could be all in one dimension. This could work for linear motion. And then, of course, for projectiles, just say, well, and there's an X direction and a Y direction, but it's no new formulas, the same formulas, right? Next week, we're going to start getting to, guys, do you see the one right beneath it says acceleration is net force divided by mass? You guys see that? Right. That has a name. Does anybody know the name of that formula? Second law, yeah, that's Newton's second law of motion. Yeah, right there. So that's going to be next week. We'll do that. All right, so let's talk about these three kinematic formulas a little bit. Now I blew them up here bigger. This is how AP writes them. You might notice they're written slightly differently than how I showed you in class. Right? So straight off the poster, it looks like this, right? And then AP writes them like this, right? So notice a few little differences. I mean, there's like 10 different ways you can write these formulas. So right, it's what you're doing. Okay? So one thing AP did was they put subscripts X all over the place to say like X direction, X direction, X direction. They're really trying to emphasize that any of these formulas that you apply are only in one direction. Over the past week, I've seen some, just among all my classes, kind of mix and match, like, oh, here's a little bit of horizontal information here, a little bit of vertical here, and shove it all in one equation. Because whenever you're applying these equations, either all the information is strictly horizontal or strictly vertical. Right? So maybe it could be like accelerating in the X direction. So something like that. So we got that. Also, they did put them in a different order. So you guys see, I've been calling this one the second one, and here's the first one. Okay, so they reversed order. Okay, so I got a little bit of that. Here's a big difference is the way I've been applying. So the way I typed this on this poster, this X could stand for a displacement, like a difference in position. If you go from point A to point B, there's some kind of displacement. Right. Same thing with this X. You guys see this X and this X displacement values, right? It's like what's the change in position, right? But AP gets a little bit more specific. They're doing this not in terms of displacement, but in terms of position. So you guys see this kinematic formula here. This is what I've been calling the first one. Right? But they put it second. Final position equals initial position plus, and then B naught T plus half AB squared. You see that? Right. Now, if you just subtract over X naught, you could do X minus X naught. That'd be like a change in position. You could also call it delta X. Oh, and that could be a displacement. Now, I just called it X, but really it's like a change in X. You guys see that? Right. Some of the progress check puzzles that could be helpful. If say like if you start at position 2 meters, and you end up at position 7 meters. You guys see that would be a displacement of 5 meters from 2 to 7 would be a displacement of 5. Okay. Right. And then same thing here. Hey, look at this. For again, in the final kinematic formula, the time independent one. So again, I'm calling X a displacement. So difference between point A and point B. And AP spelled it out. They said we're going from point A to point B, so we take a difference. Okay. You guys see that? And then when you guys go to college and you open up a college textbook, they might have them written, possibly slightly differently again. Right? There's like 10 different ways you can write these things. Yeah. All right, so just heads up there, be aware of that. Trying to navigate this. All right, let's take a look at okay, you guys' quiz here. Here's your take-home quiz. Well, one of the versions, right? There's 2 different versions floating around. But I think I gave everybody a similar type scenario here, which is a cannon blasts a cannonball at some speed at some angle above the horizontal. The cannonball strikes a castle wall that is so many meters downrange. Say horizontal displacement, so many meters away is the castle wall. Okay? So all the following graphs. We got height versus time. This is, of course, for the cannonball. What's the vertical component of velocity versus time? You guys see like v sub y. Okay. And then the final graph is, wait, what did I just say? I said vertical component of velocity versus time, v sub y versus t. And the last one's horizontal component of velocity versus time, v sub x versus t. So careful, it's not an acceleration graph. It's a different type velocity graph. We're thinking about 2 different directions here. Okay, so let me help you guys out with at least a couple of these graphs. Right, maybe I'll leave at least one to you guys entirely. Okay, so let's focus on v sub y versus t. It's gonna be in meters per second, seconds, and then later on we'll look at v sub x versus t. Then meters per second. Right. Okay. Did I? Yeah. All right. All right. I got to extend that into the negative territory a little bit. Here we go. All right. So we're talking about cannon blast and a cannonball toward a castle wall. I might pick up this. I bet this poster could be pretty good. Think about how to put the graphs like this. Okay? So here's the full scenario. Okay, we blast some speed, some angle, power, okay? And I'll look components. I see horizontal component, which stays the same all the way across. I see a vertical component, which changes by how many meters per second every second? 10, because Earth gravity. Okay? Ooh, so do you guys think you could, say, at time 0, where would you guys say, now did I specify up was positive? Did I say that? Did I say, yeah, let's call up positive. If up is positive, then right where the cannon falls, leaving the cannon, it's traveling. Can you guys do an initial velocity point? Would you guys maybe do something like this, maybe, or something like that? Okay. That could be v naught. Okay. Okay. So see, right when the cannonball's even, hey, maybe I'll graph this. Right? Maybe I'll if I have exactly these numbers, could that be 30 meters per second right there? 30 meters per second. Right. Then after 1 second, it's traveling up how fast? 20. So maybe it can make coordinates. Let's do some coordinates. Let's say it's like 1, 2, 3, 4, 5 seconds. These might not be your numbers, but you guys get the idea. If this is like 30, put a 30 up there, 30 meters per second. Okay. So after 1 second, now it's down to 20 meters per second. And after 1 more second, now it's going to be down to 10 meters per second. After another second, it's traveling how fast vertically? 0. And see, this is 0 meters per second vertically. Right at the very top. Right? Is that like point? Maybe right about there. Right? And then then it starts to pick up speed, but in the negative direction. If down is negative, right? 10, 20. So maybe it goes like point. Maybe something kind of like that. Ooh, guys, and what shape is that right there? That would be linear, wouldn't it? If I drew that right, something about like that. Okay. Guys, what does the slope of this represent? Yeah, acceleration due to gravity, maybe gravity field, acceleration, vertical. Okay. What is the, hey, what is, here? Yeah, displacement. In fact, if I just hatch in that triangle, specifically what displacement? The maximum height. Aha, that would be the maximum height. Right. And then it goes negative. So now cannonball's coming back down. Right. If it hits the castle wall before it's the ground, you guys see which triangle is going to be bigger? I don't think they're the same size. Okay. All right, let's switch over to v sub x. V sub x. So here's how fast it was traveling horizontally, leaving the cannon. Right. And then 1 second later, it's traveling Ooh, same speed. 1 second later, 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 same speed. It's always going. It's the same horizontal component of velocity. So let's throw in 1, 2, 3, 4, 5 seconds, maybe. Okay, so it left the cannon. It was going horizontally at like 40 meters per second. Then 1 second later, it was going 40 meters per second. 1 second later, 40 meters per second. 40 meters per second. 40 meters per second. 40 meters per second. Right, of course, this is strictly in the horizontal direction. All right, so connect the dots, point. You guys know what that graph's going to look like? All right, so I want to walk you guys through that a little bit. Again, because I know you guys had some graphs also on your first quiz, and just I want you guys to see the answers, but gotta get all those in first before I get into this back. All right. All right, you guys ready for FRQ? FRQ.